There are a number of well-documented challenges that listeners face when tasked to identify speakers. Factors such as environment, transmission, and other speech modalities can subvert methods used by listeners to classify speakers. Despite these obstacles, studies have shown listeners use acoustic features to make discriminations and identify speakers. It is clear that perceptual speaker identification, or SID, is cognitively complex and combines acoustic and decision-making processes. In addition to developing high-quality speech recordings that capture idiosyncratic speaker characteristics, the methods used to present speech materials are also influential on listeners. The collection, selection, and presentation of speech materials is at the core of research pursued by forensic phoneticians. Decisions regarding which speech recordings to select and their sequence have the potential to influence witnesses and interpretations of evidence. With respect to presenting materials and findings of judiciary proceedings, it is of utmost importance to eliminate or minimize any biasing features. There are a number of different perceptual SID tasks. Oftentimes, forensic phoneticians develop speech recording lineups or voice parades as a way of collecting evidence. However, the process of transforming a visual lineup into an auditory one is difficult. Major concerns have been addressed over their design, where witnesses are presented a collection of speech recordings and are tasked to identify whether a target is present or absent from a speaker set. Numerous studies have detailed that listeners were inefficient at identifying targets, and the lack of consensus surrounding the number of voices to include in a lineup is problematic. A much simpler perceptual SID method employs a binary approach, where listeners are tasked to determine whether two speech recordings belong to the same speaker or not. This approach is the basis of automatic speaker verification, or ASV, system models. Oftentimes, this approach requires numerous tests, which can be time-consuming for listeners. In addition, there are concerns that a binary-based perceptual SID tasks are encumbered by memory bias, as listeners may perceive or recall speech characteristics relating to speech recordings in previous binary trials. As an alternative to these approaches, we propose the development of a perceptual clustering method, which is often employed in the domain of machine learning. In general, listeners are tasked to cluster similar speech recordings into speaker-specific clusters. In this way, listeners are able to personalize their engagements with speech materials and organize their proximities in relation to their perceived likeness. Clustering tasks are designed to be open and more evocative natural interactions between speech listeners, as opposed to more artificial tasks that restrict listener expression. The primary goal of our study was to examine the effects of perceptual SID task design on performance by listeners. It was of interest to study whether design features such as the method of response and the number of stimuli presented per trial influence SID performance. Following the collection of listener responses across different SID perceptual tasks, our second goal was to examine their relationships with scores generated by a custom ASV system. By reporting the findings from our application of correlation procedures, we aim to add to the developing research that addresses acoustic perceptual correlates in the context of human SID and ASV performances. Speech recordings from 10 female and 10 male native French speakers were selected from the PTSVOX database. The speaker details are outlined on the table. Each speaker recited the same 3 French texts. We extracted 24 speech fragments, or chunks, for each speaker. 5 female and 5 male speakers were randomly assigned to an inset speaker target group, while the remaining speakers were assigned to a distractor out-of-set group. Similarly, 12 chunks were evenly distributed in the inset and outset speaker groups. Experiment 1 participants completed 2 tasks at the LPL computer laboratory. The gender of the speech recordings alternated for the 2 tasks, which were counterbalanced between participants. Participants completed 30 target lineup or TL task trials. For each trial, they were presented a target speech recording and 5 speech recordings that constituted a lineup. The target chunk was different from the lineup speakers, who all recited the same chunk. Participants used a custom interface illustrated on the slide to determine whether the target speaker was present in the lineup. Participants were unlimited by the number of speech recording listens. Participants completed 100 same different or SD task trials. Each SD trial began with a short sound produced by a sinusoidal oscillator. A speech recording was automated and synchronized with voice A text displayed in a yellow rectangle on the computer screen. This was preceded by a short silence, followed by a second speech recording with voice B in a blue rectangle. The gender of the 2 speakers was the same, while the utterances were different. Participants had 5 seconds to determine whether the 2 speech recordings belonged to the same speaker or 2 different speakers by pressing the right or left buttons, respectively. Experiment 2 participants completed a series of 10 cluster trials on their personal computers by accessing a website that provided them with a custom interface developed at the Laboratoire Informatique d'Avignon. Each trial was composed of 12 speech recordings represented as numbered circles. Participants were tasked to listen to each recording and classify it into a cluster, which represented a unique speaker. The minimum and maximum number of clusters permitted per trial were 2 and 6 respectively. The number of trials and stimuli differed per task. The table illustrates the main task design elements. For more details on the selection of speech materials used across the task, please review our paper. 35 native French speakers participated in Experiment 1, mean age 26 years. A different group of 20 native French speakers participated in Experiment 2, mean age 26 years. All participants reported good hearing. Our primary goal was to evaluate and compare perceptual SID performance across different tasks. For each participant, we calculated a trial score. For the TL and SD task, participants received a score of 1 for each true response. For each cluster trial, we first identified each cluster that contained an inset speech recording. We then calculated a cluster score based on the number of inset speech recordings in the cluster divided by the total number of speech recordings in the cluster. In addition, we measured different task-dependent metrics, as illustrated on the table, to examine whether they correlated to performance. As the number of stimuli per task differed, it was important to establish a baseline for which to compare participant performance. For each task, we performed multiple simulations of randomly selecting the correct response after 10,000 trials. The figure on the right illustrates our findings, where the TL task yielded a 16% correct response, the SD task yielded 50% correct response, and the cluster task yielded 46% correct responses. We took these simulated calculations per task into account to calculate an adjusted score. Mixed ANOVA procedures were carried out on the mean adjusted score per trial, with the task type as the between subject factor and speaker stimuli as the inter-subject factor. Where main effects were detected, post-hoc t-tests were carried out. To examine whether there were any relationships between participant responses and acoustic features found in the speech recordings, we obtained objective results by means of an ASV system that relies on X-vector speaker embeddings and probabilistic linear discriminant analysis, or PLDA. We developed two ASV systems with the Caldi toolkit on different datasets. The first model was trained on the LibreSpeech dataset, while the second ASV model was trained on the Vox Celeb dataset. The models have factorized time-delay neural network architecture, and were trained using a cross-entropy criterion, as described in detail in the paper cited below. The ASV models were used to obtain PLDA scores for evaluated pairs of speech segments, as outlined on the slide. The equal error rates for each model are illustrated. For each participant response, we calculated an objective score based on the SID task using each ASV model. The table illustrates the distribution of total participant responses and percentages across the different experiments. We observed similar trends between the ST and cluster tasks, where the sum of true positive and negative responses for the ST task was similar to the true positive responses for the cluster tasks. In comparison, the TL task had similar true positive responses, but we observed an increase in false positive responses. For both female and male speaker stimuli, we found main effects for mean adjusted score on task type. For female speaker stimuli, post-hoc t-tests revealed that participants had significantly higher average scores when performing the ST task when compared to the TL task. For male speaker stimuli, post-hoc t-tests revealed that participants had significantly higher average scores when performing the ST and cluster task when compared to the TL task. The table and figures illustrate these findings. The following describes our results from applying Pearson correlation procedures to subjective and objective metrics. For both TL and cluster tasks, accuracy positively correlates significantly to likelihood scores generated by both ASV models. In general, these findings suggest likelihood scores generated by the ASV models provided a good measure to the perceptual performance of participants tasked to identify speakers, as an increase in mean adjusted score correlated to an increase in the similarity between selected speech recordings. For the ST task, although we observed a significant negative correlation between response time and adjusted score, we reported weak correlations between subjective and objective metrics. Our comprehensive results are described on this slide. The primary goal of our study was to examine whether the method of presenting speech recordings affected perceptual SID performance. Our findings showed participants performed the task differently, where the SD and cluster tasks facilitated a better platform for discriminating and identifying speakers when compared to the TL task. The absent target feature distinguished the TL task from the other tasks, and our preliminary results were proven to have a significant effect on the performance accuracy. These observations confirmed our hypothesis regarding the relationship between task difficulty and the variety of strategies employed by participants. Both TL and cluster tasks showed strong correlations between subjective and objective metrics. While correlations with responses from the cluster task yielded similar row values for both ASV models, we observed a slight difference in correlations for the TL task depending on the likelihood scores produced by the ASV models. This finding suggests the TL task produced responses that correlated differently, around 10%, depending on the dataset used to train the ASV models. On the contrary, the cluster test yielded responses that correlated quite similarly, around 3%, with likelihood scores generated by different ASV models. This observation suggests the cluster task was more robust, as the data set used to train the ASV model played a less influential role on measuring acoustic perceptual correlates. Taking all of these observations into account, the most promising results came from the cluster task. A key distinction of the cluster task was that it allowed users to dynamically engage with the speech materials in highly personal ways, while the other tasks limited unique expression. Both the TL and ST tasks demanded listeners a simple binary question that to some could be perceived as artificial. From this perspective, a clustering task is ideal, as there is no distinction between in or out of set speakers, but rather a set of speakers that requires listeners to organize. A clustering task was designed to be open-ended by inviting listeners to make speaker identification estimations by arranging and grouping speech materials. Any errors were represented as proportions, which minimized the severity of the penalties incurred for incorrect selections. They also offered us listening profiles for each participant. Moreover, our findings highlighted how participants performed at a high level, which correlated slightly to other performance metrics and strongly to likelihood scores. This paper detailed our development of 3 perceptual SID tasks with similar speech recordings. Our findings underscored the effect of presentation on performance accuracy, as well as the selection of stimuli, and served as an important benchmark for evaluating perceptual SID task designs. While optimizing performance is important, its value depends on whether the task permits its users to make correct choices. As the target absent option is typically presented in the domain of forensic phonetics, future studies might consider examining the threshold of this negative effect on accuracy in relation to the number of voices in a lineup. Several design and environmental factors might explain the high performance by cluster participants. Although they listened to 120 speech recordings in total, participants completed trials on computers in their personal environments and were permitted to re-listen to and take pauses between recordings and trials. Future work might consider ways of limiting the use of similar speech materials. We plan to continue developing studies that involve the cluster task by examining the mixed effects of stimuli selection, the speech recording conditions, number of stimuli per trial, and the limited mean number of listens or time to complete each task. While we observed significant differences between tasks, in general, our findings revealed that participants performed quite well. These findings demonstrate that despite the complexity of the task, participants were capable of giving correct responses at a higher rate than randomly making selections. The development of different tasks provided us with the means to evaluate the effect of context, or rather task design, and its influence on listeners making responses to similar speech materials. As a way of gaining insight on the perceptual limitations of listeners, future work seeks to develop a methodology to test a series or combination of tasks. By doing so, we might observe and identify associations between speech idiosyncrasies with listener profiles. Our findings illustrate that each perceptual SID task has the potential to deliver different observations depending on the context and situation of the speakers. Thank you again, and we look forward to responding to your questions and comments.